In this video, we'll solve some more problems based on conservation of energy and collisions. So here we have been given the graphs to represent kinetic energy before and after collision for three collisions A, B and C. Which graph represents an inelastic collision? So first we need to understand what's the difference between elastic collision and inelastic collision. So in an elastic collision, total kinetic energy before the collision is equal to total kinetic energy after the collision. Whereas in inelastic collision, total kinetic energy before is not equal to total kinetic energy after the collision. Now if you look at graph A, we can see that kinetic energy before is less than kinetic energy after, which is not possible. So you have got more kinetic energy after they collide, which is not a possibility, so we can cancel that out. Then in second graph, that is B graph, you can see that kinetic energy after is less than kinetic energy before, and in C graph, kinetic energy after and before, they are equal to each other. That means B is inelastic collision. So the graph which represents inelastic collision is B, and obviously C, where kinetic energy before and is equal to kinetic energy after, that should be the graph for elastic collision. Let's solve another problem. An electric motor takes 1.1 minutes. That means the time is given to us as 1.1 minute, which we need to convert to seconds. So we'll multiply by 60. That will give us 66 seconds. So an electric motor takes 1.1 minute to lift a box weighing 33 kg. The mass is given to us as 33 kg through a vertical distance of 191 meter above the ground. So the height is given to us as 191 meter. The question is asking us what is the work done by the motor to lift the box. So work done will be Fd. The force will be the weight of the box. So we have been given the mass. So the force we can replace by mg, weight is mg, times the distance is the height. So that's what we have to remember here. They did not give us the force directly. Instead, they have given us the weight, the mass of the object. So we have to find the weight, which is force of gravity, using the formula mg. So for work done, we'll write mgh. And we have all the numbers here, 33, 9.8 and 191. And we can get the work done as 61,769.4 and the unit is joules. Next is asking us how much power does the motor develop in lifting the box. So we want to find what's the power. Formula for power is work done over time. We already calculated the work done. The time we convert it to seconds. We substitute the numbers and we get the answer for power as 935.9 watts.